if we're talking about salt being the solute. Realize that these terms right here, iso, hyper, and then the following one, it's describing the amount of solute, not solvent. So if we're talking about salt water, a hypertonic solution means there's a lot of salt. An isotonic solution would mean that there's the same amount of salt inside and outside, okay? So these prefixes right here, these describe the solute concentration. Iso means the same, right? So iso would be like the exact same concentration of salt outside and inside the cell. Hypertonic would mean that one side has got way more salt. And then, does anybody know the third one? What is it?
Hypotonic.
Hypotonic, okay? Hypo means low. It's like the opposite of hyper. And again, these prefixes are describing the amount of solute that's in the solution. Remember, every solution has got a solute and a solvent. What is the universal solvent in biology? Always, 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 the solvent is what?
Water.
Water. So it's easy. You know that the solvent is water. The solute is the stuff that's in the water. Okay? Melanie and Sina, make sure that when we're done with this, I change attendance. Otherwise, you guys will, because I took it before you came in. Okay, so I'm going to erase my little markings up here, and then we're going to talk about what's going on here. I'm going to draw next. Bet you can't wait. Everybody good? Need more time? We good? We good? Okay. So let's take a look at what happens when we have a cell. So I'm going to draw. Here's my plasma membrane. So there's my cell. We've obviously got inside the cell, this is my cytosol. I'm just going to start using biology terms. This is my extracellular fluid. Remember, extracellular means outside the cell. And let's say we place a cell in what we would describe as a hypertonic solution. So we're going to make the solution out here hypertonic, and we'll talk about what that means. Now, if the outside is hypertonic, what's the inside have to be relative to outside? So if this is hypertonic, this must be what? You see that? If one's hyper, then that has to be hypo. Okay? So we're going to say that this is clearly, if outside is hypertonic, then inside must be hypotonic relative to each other. And remember that those terms hyper and hypo are referring to the amount of solute. So here's an example. We know that water exists everywhere. So I'm putting blue dots everywhere. It's kind of annoying, I know. It's annoying to me too, but there's water everywhere. Outside is hyper. So what we're going to use here is alcohol. Let's talk about what happens when people drink. Alcohol is large and polar. Alcohol is generally not welcomed inside cells. It's not something that's produced biologically. Your body doesn't make alcohol and then send it to your cells for a good time. It's an outside substance that you consume, which means there's no membrane transport proteins to get alcohol into your cells. So what ends up happening, in this case, I'm going to use red. We have a bunch of large polar alcohol molecules. Because you had a drink and then you had, well, I'm not saying you, because you would never do that. But somebody had a bunch of alcohol. So clearly, can you see that this is a hypertonic solution outside? Which means that there's no alcohol inside the cell, so that's clearly hypotonic. We all good so far? Do you see why we would label this as being hypertonic? Okay, here's how you solve these. I'm telling you right now, if you will do it this way, you'll never miss one. If you decide that I'll just, you know how like in math, some of you guys, and there's 2 or 3 of you in here that are like, I don't need this method, I know. but just do it initially so that you don't make mistakes. It's kind of like when you think like, oh yeah, I can just do the mental math, and then you get to a slightly more complicated problem and you're like, oh, I can't do that mentally anymore, and now I don't actually know how to do it because I've just been kind of solving it in my head. These will get complicated. So the initial ones, please just track along with me. If you'll use this, I swear to you, you'll never miss it. Okay? So, I'm going to draw myself this little T-chart. And I'm going to draw one outside, and I'm going to draw one inside. I'm going to make it like that. Okay, and what I'm going to do is, in each one, I'm going to put solutes. Because we realize that a solution has solute, but it also has solvent. And it also has solvent. I'm telling you, this is so easy. I wish somebody had taught me this. I went through all of college and grad school and parts of like just memorizing this. In fact, I can tell you, my first maybe 7 years as a biology teacher, I would teach this, but I'd teach it like really kind of fast and kind of over the top. Like, yeah, you'll learn this later because I didn't really understand it. Like I straight up didn't really get it. I had always memorized it, so it was difficult for me to teach. And then when I started teaching AP Bio, I realized like, oh dang, I need to actually know this. And I came up with this method, and I'm like, why didn't somebody teach me this? You'll never forget it if you do it this way. So what they've told us is let's talk about always start with solute. Because in some cases, they'll just tell you a cell was put into a hypertonic solution. You already know everything you need to know. Here's what you do. Out here, all we have to do is draw arrows. Is the solute high or low? Out here, outside the cell, in the extracellular, high or low? High. Which means if it's high out here, then it must be low in here. Any questions so far? Okay, and then you know that now the problem is literally solved at this point. Because it's always an inverse relationship. If there's high solute concentration, that must mean that the solvent, that means that the water is less highly concentrated, so that would be a down arrow. And if it's down, if the water is going, if it's low outside, then it must be what inside? High. You see that relationship? It's an inverse relationship. As long as you know the solute, you're done. Like it's easy. Now, somebody remind me, because you just wrote it down. So what needs to happen here? The alcohol can't cross. Since the alcohol can't move, water has to. What's the definition of osmosis? Diffusion of water. Diffusion of what? Water. And diffusion is always what to what? Diffusion is always high to low, which means the water is going to leave the cell and go outside, in essence trying to dilute the alcohol so the alcohol looks less concentrated outside the cell. You see which way the water would move here and why? And guess what ends up happening? When you drink, depending on how much you drink, this happens, and you wake up the next morning and your cells are like all shriveled up. It's called intracellular dehydration. That's a hangover. That's what it is. Not only do your cells dump water into your bloodstream, but then because alcohol is a diuretic, it tricks your like you don't need to know that term. It tricks your kidneys into thinking I've got too much water, and so what you do is you pee away the water. So not only are your cells puking out all their water into your bloodstream, but then your kidneys are going, whoa, we got way too much water, and you pee away more than you need. So you wake up like extra dehydrated the next morning. That's what a hangover is. It's intracellular dehydration. And it's a result of osmosis. Questions? No? Now, how could they have asked you this? Let's do another one. Sorry. Biosustainability stuff. All right. Let's say I gave you this. Here's another way they like to say this. We're dealing with they tell you a cell, the conditions inside the cell are you've got a 0.5 molar solution inside the cell, and outside the cell is 0.8 molar. Now, if you've never taken chemistry before, that's just a measure of the concentration of the solution. This is always a description of the solute concentration. What we're talking about is not the water, but how much stuff. We don't even need to know what it is. If they just tell you that you've got 0.8 outside and 0.5 inside, you can solve this. Okay, instantly what you do is you go this and this. You know you've got solute. You know you've got solute in here. You know you've got solvent, which is water, and you know you've got solvent. Remember that if they give you something like this, that's describing the amount of solute that's in the water. So you guys tell me, where is it more concentrated, outside the cell or inside the cell? Outside. The bigger number means more of the solute, which means we would be high in solute there, and if it's high outside, then it must be what inside? Low relative. And now you know that the water is always an inverse relationship, so this is easy. And we know that diffusion is going to have to happen, which means we're going to go from high to low, right? And so we could have labeled these solutions. This one outside would have been hypertonic. The one inside, relative to outside, is hypotonic. Make sense? It's the exact same problem, just using numbers rather than using a bunch of big A's on the board. This is how they like to ask you stuff on the AP exam. They'll give you the concentration of the solute. Yes?
Will they ever give you like the pH instead of the molar? Oh, okay.
Nope. pH, like in this, I mean, it obviously matters. Biologically, it does matter, but they'll never ask you that on the test. Okay? We good here? Okay, so we understand that. Now, like, we don't even really need to do isotonic. Well, I guess we should. So let's do one. What if I gave you a solution? Let's say that they tell you that a cell, exists. And again, it doesn't even matter what we're dealing with. It's 0.4 molar inside, and then they tell you that it's 0.4 molar outside. Those two solutions are what? Hypertonic, hypotonic, or isotonic to each other? These are isotonic, which means we're good. We're good. There's going to be no net water movement. Now, that doesn't mean that water's not, slowly trickling this way and that way. There's always water moving back and forth, but there's no net movement of water out or inside of the cell when conditions are isotonic. We good on that? Okay, then let's do hypotonic. So now, let's say we've got a cell, and cells normally have sugar in them. Like that would make sense to us, right? Because we know that we burn sugar for fuel, and sugar is like, so let's put some sugars in there, okay? So let's say I've got some sugar, a normal amount of sugar. And we know that water is everywhere. But what we've accidentally done here is we've dropped a cell into distilled water. Does anybody know what distilled water is?
Is it like pure water?
It's just pure water. It's water with no solute. Right? You can get distilled water is essentially something, we can talk, it's not chemistry, we're not gonna talk about how you distill water, but distilled water means just water, no solute whatsoever. Zero solute. It's just water. Whoa, clearly something is gonna have to happen here. Okay, so we've got, let's draw our little T thing here. And we know that we have solute we got solute, we've got solvent, we got solvent, and let's start outside. How much solute is there relative to inside? Is it low or high? It's low. There's no solute. So it's obviously low here, which means it has to be high there. And can you see how now the problem's solved? Like it's done, because you know that the water is an inverse relationship. Osmosis is going to have to occur, and osmosis is the diffusion of water, meaning water is going to go from high to low. And water is going to go rushing into the cell. If you take a cell and you put it in distilled water, what will happen is the cell will swell and swell and swell and swell, and eventually it'll go pop. Pop goes the weasel, and the weasel goes pop. It'll call its lice, it'll break. So you put a cell into distilled water, it'll swell, 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 and then pop open. Because the water will just keep rushing in because there's no solute. out here. So the water just keeps going in until the cell pops open. Make sense? So if we had to label these solutions, what would you call the solution out here? Distilled water? Is this hypertonic, isotonic, or hypotonic relative to inside? This is hypotonic. So outside here would be hypotonic, because remember, hypo is referring to the amount of solute, which is obviously low out here. The inside solution, if we had to label it, what would you call the inside of the cell relative to outside? Hypertonic. It's not hard, is it? No? It's relatively easy, yes? Questions? Okay, then let's go back to the slide deck and look at some biological looking pictures. Okay, so we've already covered this. We've gone over the definitions of iso, hyper, and hypo. So this is a classic, this is just a U-shaped tube, and what's in between, you don't need to know the name of this, right? But this is called capillary tubing, and there is some semi-permeable membrane here, okay? It's semi-permeable, and we can see here that what we have is we have some sugar, right? Higher concentration, meaning this side over here is hypertonic. This side over here, if that's hyper, this is lower, that must be hypo. So let's do our little T-chart just so we can explain why the water is moving. Okay, this side versus this side. We got solute. We've got solute. We've got solvent. We've got solvent. And so it says right here, lower concentration of solute. So you know that's low. That means this one must be high. And we know that the water is always an inverse relationship. And so we know here that what's going to happen if the solute, the sugar, can't, like they're showing it to you here. See how the sugar molecule, these big green things, they can't go across, but the water obviously can. So since the solute, the sugar can't move, the water has to. And we know that osmosis says, right, water is always going to go. It's the diffusion of water from high to low. And so what happens, if you have like 2 days, you can set this up. You can get these little U-shaped tubes. Right, it's a classic freshman in biology major, freshman in college biology major lab. Right, you set it up and you come back 2 days later and you set up that you make 2 different solutions. You pour the exact same amount into both sides, and then you come back like 2 days and you're like, ooh, because it's just water, but it's like, ooh, it's unbalanced. Whoa, what happened? It's magic. No, it's osmosis. The water had to move because the solute couldn't. And so what you end up with is this imbalance in water levels, but it's a result of osmosis. Make sense? Yeah? You sure? Any questions? This is too easy. It's too easy, right? And yet, I'm telling you right now, roughly 2/3 of AP Bio students don't understand why water moves, or which way it would move. Let's finish up this next couple, I think there's 1 or 2 more slides. And then I'll tell you the Chewbacca story. It actually has to do with osmosis, so it just takes a while to get there. So let's look at how a cell would respond in different conditions. And let's realize that there's a difference between plant and animal cells. What's the main difference like that you can see here between an animal cell and a plant cell? What does a plant cell have that an animal cell doesn't have? A cell wall. Which means it's good in some cases to have a cell wall, but it's bad in other cases, okay? So a hypotonic solution, meaning that the cell is placed into a hypotonic solution. So let's just go ahead and we'll make our T-chart just so we make sure we understand. That's the outside solution, and then the inside solution, I'm going to draw it right here next to the cell, like this, right? That's indicating the solution inside. So if we place the cell in a hypotonic solution, that means that it's for solute. We've got solute. We've got solvent. I mean, they're already showing you which way water is going to move, but let's just use this as practice. Right? Hypo means what? High or low? Low, meaning that this is going to be low, which means this must be high. We know that water is always an inverse relationship, high, low, and so as a result, we know the water is going to move into the cell, right? And so what can happen, this is like if you place the example that I gave you. If you place an animal cell into distilled water, the water will like keep running in until the cell literally lyses and pops. Plant cells don't have that problem because they have a rigid cell wall. Plants don't have a drinking problem. They can like take on a bunch of water and they never pop because eventually the plasma membrane will just like bump into the cell wall and that's it. It can't take any more water. So you see the difference? Okay. Isotonic, clearly no issues. Now let's flip over to hypertonic. This is our alcohol situation. That right there, that's a like shriveled. That's intracellular dehydration like we talked about. That's like a hangover. Right? When all the water leaves the cell. The problem with the plant cell is the plasma membrane every so often is actually physically anchored to the cell wall. And so if the cell shrivels up too much and the plant gets too dehydrated, what happens is these things rip off the wall. The plasma membrane, like literally the cell shrivels up too much and then it tears off and it rips a gigantic hole in the plasma membrane and that cell is like torn apart. And it's said to be plasmolyzed, meaning the plasma membrane, and lyse means to break, meaning the plasma membrane is torn off the cell wall, and that would be a dead plant cell. You see the difference between, like, there's advantages to being a plant, right? You can never have enough water, right? Pure water is just fine, you can take it on, right? Versus, right? Plants can't get it. Plants get a hangover. Plants don't drink alcohol, but you get the idea. If a plant gets too dehydrated, the cell wall, the plasma membrane literally rips off the cell wall. You good? This is osmosis. You ready for the Chewbacca story? You sure you want to hear this?
Yeah.
You sure?
Yeah.
Okay. So, in med school, in year 2, your first year, you just take classes. Like you're in class like all day, 12 hours a day. They're just jamming information into your, like shoving it down your throat. In year 2, you start your rotations, which means you go and you spend about like 4 weeks doing, orthopedic, and then you spend like 6 weeks doing OBGYN, like gynecology and helping to deliver babies, and then you do emergency medicine, and then you do this, and then you do that. So you also have a psych rotation. So I went to UCI Med. I did like the first 2 years of a PhD MD program. And on the psych rotation, we went to a lot of different hospitals and a lot of different like psych facilities. Everything from like outpatient treatment centers where people with like diagnosed, verifiable like mental health issues like would go for outpatient services. We also went to inpatient where like, it's 24/7, they're there. We went all the way to like 24/7 like lockdown facilities where the people that are in there are a danger to themselves or others. There's a couple psych facilities in Southern California that are straight up for like identified sociopaths, people that have done weird things like cannibalism or yada yada yada. And this was not one of those. This was a lockdown. This was a 48-hour holding lockdown facility for people who had been identified as being somehow not like murderous rampage, like I'm going to stab and kill everyone, but rather just their behavior was erratic enough that like we don't know what's going on with them. They've been brought in generally by the police because somebody that was behaving oddly and people were concerned. They're standing in the middle of traffic. They're doing something. So what this was is it was a facility and it was for 48 hours and they would observe whoever was there and basically let them do whatever they wanted to do. It was just an observation facility. And then the psychs would basically like watch people and then write up reports, and after 48 hours be like, okay, clearly what we have here is this, so you need to go get that. What we have over here is you need some help here, so we're going to send you to this facility. It was almost like a let's figure you out and then send you where you need to go. Random story, sorry. So we go to walk in, it's lockdown, right? Meaning that it's got like double, like big metal doors, like the double. If you've ever been to a jail or a prison to visit or anything, there's like double doors. You walk into one and it closes behind you. And there's not bars, they're like full-on metal doors. So they tell us going in, like, listen, these people are not dangerous. Essentially, don't talk to them. You're there to observe. If they talk to you, it's okay, like you can respond. Don't ignore them. But the key is like, don't trigger any behaviors. if you do something or you say something and you see a response, like try to just don't make it worse, right? And there was no sharp objects, no nothing, right? No pen. Like the only thing we could have was they gave us pens, but we each got one pen and a clipboard, and that was it. On the inside of this double door was a room that was like twice as big as this, and it was essentially a rec room, right? There was like a ping pong table, and there were some books and a couple couches and several TVs, and just like, it was kind of like a lounge. And then off of it, there was like a wing where there was like a women's dorm, where there was like, I think there was 10 or 12 beds, and then a women's bathroom, and then on the other side, there was like a men's sleeping area with men's toilets, right? Urinals and toilets, right? So it's time to go in, and the two double doors come together like this. And so like they're like, okay, we're gonna go in. When we go in, just step in. As soon as everybody's in, then we'll close the doors behind you. And like, you know, there was people in there with us, and there was other people that were in there working, etc. So the door opens up, and I'm always first. This is like through all my stories, I always want to be first in line. Like no matter what we were doing, because that means then that if they ask somebody to do something, I'm the first one that's there. Like I want to try. And so the door opens up, and I'm standing right here, and the door goes, and standing in front of me is Chewbacca. And I say that he's Chewbacca. He's a man who's probably about 5'2", 5'3" maybe, and he's about at least 250, 270 pounds. Like he's short and really round. And I call him Chewbacca because he was the hairiest man I've ever seen in my entire life. He looked like, what's the guy's name? Zach Galifianakis. You know what I'm talking about? The actor from like The Hangover.
Oh, yeah.
He looked like that guy, except he had big round glasses, like gigantic round glasses that really, like old school glasses, really magnified, so his eyeballs looked like this big. And I call him Chewbacca because, again, hairiest man ever, and he's completely buck naked. He's not wearing a stitch of clothing. And he's just full-on beard to neck beard to just matted fur. And he is, like I said, he's maybe 5'3", and he's probably 250 pounds. 250 pounds. And so he's standing about where Cena is. And I'm like, and they tell you, like, you're going to see weird stuff. Just let it go. Like, as long as nobody's behavior triggers somebody else, it's good. It helps us figure out what's going on. Like, just chill. So if you see something unusual, unless they're hurting themselves or hurting someone else, it's okay. So we've been like prompted, it's okay. And if you're in med school, you've seen everything. If you've been in emergency medicine, you've seen all kinds of craziness. You're just like, okay. So the door opens up, and this guy's standing there. He's kind of got this weird tilt like this. And so I just like step in, and he's like this far away, and he looks up at me and goes, hello, like that. And then everybody else starts filing in, and he's got this sort of unusual walk. He's walking like this. And he's, hello, hello, and he's talking to everybody, and he's walking up and down the aisle, up and down the line. And we're all just like filing in against the wall, and this guy's just like, hello, right? And he's got this really unusual walk. And so it triggers, because in psych, they teach you, oftentimes if there are chemical imbalances in the brain, and there are certain neurological conditions that trigger physiological symptoms. People get shakes, or they get palsies, or they get tremors, they get things that happen. So in my brain, I'm like, ooh, this guy's got an unusual walk. He's doing something funny. What's going on? What's this all about? My brain is like trying to figure it out. He walks up and down the row a couple times, and then finally he turns to walk away. I know now why he's walking funny. You know Dixon Ticonderoga pencils? The ones that have the green and yellow? And completely, I assume it was unsharpened. He had a Dixon Ticonderoga pencil, about that much of it. He had it between his butt cheeks. He was holding a pencil between, I don't know whether he had it actually in the holiest of holies, or whether it was just squeezing it between. But the reason he was walking so funny was because he was holding a pencil between his butt cheeks. And he turned, after he'd said hello to everybody, he turned to walk away. And that's when I noticed the pencil. I mean, there was just fur everywhere. And then you can imagine just seeing this. And as he walked away, it was like, go-goom, go-goom. It was like bouncing, go-goom, go-goom, like this. As he walks away, and you're like, what the fresh hell just happened to me? I feel mentally and physically abused by what I just saw. So why am I telling you this story? Had nothing to do with Chewbacca. That was just how we got into the facility. What happened next, though, is we're there after all this. This guy goes over and sits on the couch, right? The guy that's working brings on like a towel. It says, at least wrap yourself in a towel. So he wraps himself in a towel. We notice these 3 other guys that they go back to the men's dorm and they disappear. So me and this other dude were like, and they're like, obviously guys, you can't go in the women's, and women, you can't go in the guys. But like, men, feel free to go check out the living. So we go in and walk through where the like beds are, and these guys have picked up beds and they've moved them into the bathroom. Okay? And what they've done is they've laid their cots, because they're movable cots, they've laid their cots straight up against the urinals. There's no dividers between the urinal. Like ladies, I know you've at least seen a urinal. It's one of those bathrooms where there's just like 5 urinals lined up against the wall. No dividers between them. And these guys are laying, must have been 6 because there was 3 of them. Yeah, must have been 6 because there was 3 of them. They're laying facing the urinal, and they've got their head in one urinal, they've got their pants pulled down, and they got their junk in another urinal, and the urinal next to it. So like spanning 2 urinals per guy. And what they're doing is they're reaching up and they're pulling the lever, and they're filling up the bowl at the bottom. They've removed the little air freshener mints out of the bottom, and they're drinking out of the urinal. And they're drinking and drinking and drinking, and then they're laying there so that they can just pee directly into the urinal. Because like if you drink a lot, you gotta go pee. So they're just laying there, and we're like, what the hell? And we're like, well, I guess if they want to do it, that's fine. So we like take some notes, like dude's drinking out of the urinal and peeing in another one, like So eventually, though, we're kind of like, this is weird. Like, this can't be good, drinking out of a urinal. So we go back out and we find the psychiatrist that's like wandering around taking notes, and we tell him, we're like, hey, there's some guys in there drinking out of a urinal, and he's like, oh, again? And I'm like, again? Like, what? So what these guys were doing is they had mental health issues, but they were addicts as well. So what they were doing was something similar to this. They were drinking so much water that they were making their blood hypotonic, right? Like your blood's like Kool-Aid. They were adding so much water that what happens is it throws your blood chemistry off. People die from this every year. I guarantee you this summer, somewhere in the United States, some high school football player has died because he got a cramp and his football coach told him, you didn't drink enough water. And so after practice, he chugged 2 gallons of water in like an hour. And what happens is you throw your blood chemistry off enough, there's too much water and not enough solute, and you can kill yourself doing that. If your blood chemistry gets too far off, you die. But guess what happens just before you die? You get high. And so you can get high off, you can't get high. Yes, you can get high off of water just before you kill yourself by diluting your blood too much. And so these guys had heard this, that you can get, if you drink enough water, and these guys were addicts, and they were just like, screw it, let's go get high off water. And they were drinking water, trying to dilute their blood enough that it made them feel different. So considerations for you, things that you might not know. Because I'm going to there's another story later in the year about a homeless woman. It's a tapeworm story. Some of you that have siblings, you can ask about the tapeworm story, because it's another one that I tell. Consideration, did you know? Because most of the people that are in these facilities are homeless. And you know that as you walk around cities and in the United States, you see people living on the street that are clearly homeless, and you see erratic, odd behavior from them. Realize this, you might not know this. The average homeless person has an IQ that's roughly 15 to 20 points higher than the non-homeless. That homeless people on average have higher IQ than non-homeless people. They're generally of very high intelligence, but what tends to happen, these are high intelligence people that have brain, biochemical imbalances in their brain. And what ends up happening is they know they're not right. They've never felt right, right? People generally like that, they don't do well in school, because don't tell me what to do, because I'm smarter than you, and don't tell me what to do. People like that generally don't hold down jobs very well. And in the United States, if you don't have a job, do you have generally access to health care or good health care? No. And mental health care for the homeless is almost non-existent. Number one, if you're homeless and you don't have a job, you have to apply for Medi-Cal to get it. Medi-Cal, mental health support, is almost invisible. There's almost nothing. So realize that homeless people generally, almost 95% of them, have diagnosed verifiable mental health, like imbalance, like chemical imbalances in their brain that they're not being treated for. And so what a lot of people do is they self-medicate. I don't have access to medication, but I know that if I drink enough or if I take enough of whatever drug I can get, it doesn't make me feel good, but it makes me feel different, which is certainly a hell of a lot better than how I normally feel. And so what you see is that with homeless people, there's a high rate of addiction, generally because there's mental health issues and there's not access to health care. And so they self-medicate and become addicts. And so that's what we were seeing with these guys. These are 3 guys. I don't know their eventual diagnosis, but these are 3 homeless guys that had brought in for erratic behavior. They were addicts and they had mental health issue. And so the primary thing was like they were just trying to get high. They didn't like how they felt in their brain, so they were trying to drink enough water based on this scenario that they would feel different. So consider, I'm not saying then walk up to every homeless person you know and then take them home with you, because that's clearly you have to be safe. But I would also say this, as a human being, be slightly more understanding, realize that that homeless person is someone's father, mother, brother, like that person like at least has a mother and a father, or she has a mother or a father, likely has brothers and sisters, oftentimes has children, right? And so again, I'm not trying to tell you like go and help every homeless person, because you have to be safe as well, but please be understanding. Yeah? Okay. Today. Tomorrow, you have a sub. What the sub is going to give you is a paper copy of the COBOL. And your job tomorrow in class is, as a table, to complete the COBOL. Like, work through it together. On Friday, you are going to have a quiz. It's going to be shorter. Okay? It's going to be a shorter quiz. We're going to keep it on paper this week, just to simplify things so that we're not trying to use the lockdown browser for the first time. It's probably only going to be 15 to 20 questions. The majority of the questions are going to be on which way does water move and why. In addition to that, obviously there's going to be stuff on active transport and the other pieces that we've covered this week. Yeah? Questions, concerns, issues, qualms? No? We're done.